So seeing as we don't have to do 7.3, which is linear inequalities, we're going to move on to the last part of chapter 7. And this is a really quick little bit of chapter 7. And it's really just an introduction to something new called functions. And, we've seen this before in the course where the textbook teaches you something new and you're like, oh, well, that's exactly what we've already done. We just called it different things. And so really, I've put in a bit of a review from chapter 1 because in chapter 1 we were evaluating expressions, and there are a lot of parallels between what we've done before and what we're going to do in 7.4 in this introduction to functions. So as a little review, we could evaluate expressions, and what we were doing when x equaled 0, we could sub that in and evaluate this. So where I see an x, I would just put a 0 in and work through subbing in 0 where I see that x. If I did all of this, there's a whole lot of zeros, and I could see that it amounts to 4. I'm going to skip B because I find it's probably something that you're comfortable doing, and it is just a bit of a throwback. If you want to take your time with B, here's the answer for it. Let's take the time for C though, because it has that good old -1 in there, and this is where we were subbing in with brackets. So I've rewritten it showing a -1 every time there was an x. The first thing I'm going to do, whoops, I forgot an exponent there, is work through just doing the exponents. So when you have an even numbered exponent on an odd numbered value, it's going to end up being a positive value, because that's -1 times -1 times -1 times negative. So it's a positive 1. And here we'd have a 2 times a positive 1. It's -1 times -1. And I'm just going to copy the rest. So now that I've done the exponents, now I can do the multiplication. Whoops. And then once I'm done the multiplication, I can do the addition. So that was really just evaluating expressions. And really, we have evaluated functions, or sorry, evaluated expressions before. We are going to do functions now. Functions are really just a different way of writing an equation. And so you can see this function notation as an f with an x after it. And the x is really just the value of x that you use to sub in. So you read this f of as a function of x or f of x. When you see this f with the x in it, it's not multiplication between two things. It's really just, asking the same for you to solve for y when x equals whatever in that little bracket there. A big thing that comes out of this is that f of x, that notation, is y. You can interchange those two bits of information, and that's really the key thing here, is that f of x is y. So that's why it says it's the same as asking you to solve for y when x is something. So f of 4 means substitute a 4 in for where you see an x, and that's going to give you what y equals. It's just a different way of writing something that you've already done before. The reason that it is a different way of writing is that it communicates a lot of information. So rather than having to give answers as an ordered pair or keep track of your work, it can be a shortcut. At this point, I know it feels like just something new you need to learn or get your head around. So in these ones, if we're given this function, we want to evaluate that function when x is 0. So f of 0 would equal 0 cubed minus 2. I'm just copying this out with the 0 in the place of the x. So f of 0 equals 5. That's the same as saying y equals 5. So y equals 5 when x equals 0. It's a different way of writing it, but it's the same thing. It's like saying that 0 and 5 would be on the graph as an ordered pair if we were to graph this funky function. So again, with these ones, I'll try and use all the words. It's definitely one that's easier when you have it shown to you. When you just read it off the page, it's hard to really see what's going on. So we're going to take that same expression, or sorry, that same function, and evaluate it at x being -3. So f of -3 would be -3 cubed, everything just written out with -3 in the place of the x. Subbing in with brackets is key. In this one, taking my time to do the exponents first. Then the multiplication. And finishing it up with the addition and subtraction. I get a final answer of f at -3 being equal to -43. And again, the key bit here is that what this really means. It means that -3 and 43 are a point on the graph because that -3 is your x value and the 43 is your y value. Last one, an easier number to sub in. This one says, again, evaluate the function, but this time you're going to put a 1 in where you see the x. So f of 1 would equal 1 cubed minus 2 times 1 squared plus 1 plus 5. I'll do the exponents first. So I'd have 3 minus 2 times 1 plus 1 plus 5. I do the multiplication. And I wind it up with the addition. Oops, what did I just do? Oh, there we go. Like, that's not right. Somebody was probably waiting for me to catch that one. 1 times 1 times 1 is not 3. It's 1. There we go. That looks a lot better. So I get a final answer of 5 here. So f at 1 is 5. What we're saying here is that y equals 5. Or there is a point 1 and 5 on the graph. Been kind of doing all of those kind of all the way. So you can answer as an ordered pair. What we're saying is that this is the x and the whole value, the whole f of x is y. So here we go, one more. We're going to just do what we just did. This time, really just showing it all out. It's the same as the question up above. So f of 0 with this one ends up being 5. And again, writing it as an ordered pair is really what we've already done, but we'd have an ordered pair of 0 and 5. So f of 0, or we could say that y equals 5, and that 0 in there is your x. That's how you can pull the information out of function notation. So we'll just play with these a little bit more on the next page. It can be used with linear equations, so you remember that f of x is y. That's the real summary here. So it says, write this in mx plus b form. Not a whole lot to do. All I would do is say that y equals 3x minus 4. That's it. All I did was switch the f of x and the y, because f of x is y. They mean exactly the same thing. If I were to go the other way here, write as a function of x, I would have to solve for y first. So I'd have minus 2x on both sides. I'd have -3y equaling -2x plus 6. Divide by -3 everywhere. And I'd get that y equals 2/3 x minus 2. Well, if I want to write it as a function of x, all I need to do is replace the y with the f of x notation, that function notation. Everything you've already done, just a different way of representing the information. Another one, so it gives you an equation and it says write as a function of x. All you need to do is solve for y. And then once you've got it solved for y, all you do is swap out the y for this function notation. F of x equals negative 3 over 5x plus 3. We could see this in the table method, so kind of going the other way when the linear equation is given to you in function notation, all you're doing here is what you've done before. So it's already solved for y, which is what we often did. We could pick values of x and solve for values of y. If I wanted to, I could write it with this function notation, right? You put the number that you're going to use as x in that little brackety thing. And it doesn't mean you're multiplying it by that number. That's just where you write what x actually is. So I'd have f at 0 equaling negative 5, or y equals a negative 5, knowing that f of x is y. Again, function notation, same things as you've always done, just calling it different words. When x is 1, y is negative 2. And the last one, figuring out the value of the function when x is 2, or evaluating the function at f of 2. I sub a 2 in where I see an x, and f at 2 is 1. So again, this gives me 3 ordered pairs, just rolling the function notation in, not any different. I've got 3 points on my line, or on my graph, whoops, and I really missed, and I could draw the line on the graph. So you've been introduced to function notation. You've seen how it applies to linear equations. Functions can also have non-numeric values. So you can evaluate them for anything. You can plug anything in for x. You can plug other expressions in for x. And so if we wanted to start with this as my function, all I do if I want to figure out what f of a is throw an a in where I see the x, and we're done. That's all you're doing. So you can sub anything in. The value of the function when x is 2h, all I'm going to do is sub a 2h in where I see the x. So I can keep going on this. I can simplify this one a little bit more and say that 4h plus 3 is the function at x equaling 2h. One more, and again, I'm just going to evaluate this function at 2 plus h. And so what I'm doing with that is where I see an x in my original function, I'm going to write what's in the bracket here. So it tells you what you're subbing in as your x value. And again with this one, there's some work I can do. I can clean this up. So I'd have 4 plus 2h plus 3. And I'm still not done because I can actually add those whole numbers together. So f at 2 plus h is actually equaled to 2h plus 7. You could have 7 plus 2h. I chose to write it in descending order. Couple more to try here. Nothing too tricky. Don't make it harder than it is. Sort of weird, but not hard. All you're doing is subbing whatever it tells you to sub in for x. And subbing in with brackets, as you can see, is pretty useful. And that has the end of our chapter 7. So we're going to move on to chapter 8. We're almost done the chapters of the textbook. This last little part of chapter 7 is a quick one. Remember, we're not doing 7.3, and we'll move on to chapter 8 next class.